So in the last video, we determined the interval of convergence for this power series. We used a ratio test, the absolute value of the ratio of the ak plus 1 over ak is less than 1, this being ak. We found that this will converge if the interval is between plus and minus the radius of convergence. As this is centered at 0, we found that the fourth root of 5e is the radius. What we didn't find was whether we include the endpoints. Does this converge at the endpoints? It can converge at one or both or neither of the endpoints. So we need to determine that. And I wrote down a limit that we went through in the last video. We determined that the limit of this limit is equal to -1. That may come up again. So how do you test endpoints? Well, we determined the interval. We determined that this power series that has a variable x in it converges when x is between some values. So just plug in the values, plug in the extreme values of that. And if you want to prove that this is true, it's not an exhaustive proof, but you can choose values in between. This is a roughly 1.92, negative 1.92. So for fun, you could plug in -1 or -0.5 or 1 or -0 or 1 for x, and all of those should converge. Well, we're not going to do that, but what we will do is we want to determine the endpoints. So we plug in, we have to test both of them. Well, in this case, since x is to the fourth power, 4 times k, regardless of what k is, 1, 2, 3, 4, k is even or odd, 4 times an even number times any number is always even. So this is the even power. Even power, negative doesn't matter. It's always going to turn positive. So when we test one, by that logic, we will have tested both. So they'll both behave the same way. So let's just plug in the positive, and this is what we're testing. So let's try to figure out what type of test we'd like to use for this. We multiply exponents. Exponent raised to the power of another exponent, we multiply. Well, this has a factorial, and it has k powers. Might like to use a root test because of these powers, however, that, just like in the last video, that becomes a little more complicated. So we're going to need to do a ratio test again, this being our ak. So we went through it in more detail last video, so I'll go a little more quickly now. So ak plus 1 is this. It's ak plus 1 divided by ak. So I'll write out ak plus 1 divided by ak, or times the reciprocal. Be very careful with your parentheses and your exponents. And so now let's keep going here. Go ahead. We'll simplify. k plus 1 factorial again simplifies to k plus 1 times k factorial. 5 times e to the k plus 1 simplifies to 5 to the k plus 1 times e to the k plus 1. Well, 5 to the k plus 1 also simplifies to 5 to the k times 5 to the first power. That's 5 to the k plus 1. And e to the k plus 1 will be ek times e to the 1. Okay, now 5 to the k plus 1. Okay, well, I could have just kept it as 5 to the k plus 1. Those are going to cancel. And now we have k plus 1 to the k times k plus 1 to the 1. That's all split up. 5 to the k, k to the k, and we have 6k factorial, 5 to the k, e to the k. All right, all kinds of cancellations here. And that's it, I think. Now remember, we're actually doing the limit of the absolute value of this as k goes to infinity. We're trying to determine whether this converges. So we're not forcing this to less than 1, just like we did in the last one. We found the x values to make this true. We're actually trying to determine whether or not this is true. So let's not leave out the e, k to the k, and then we have just k plus 1 to the k. And we're taking our limit. Alright, well e is just a number, doesn't have anything to do with k. We can factor that right out, and we get e times the limit of all of each of these bases are being brought to the same exponent, so we can combine them. And this will probably look familiar. We did this limit in the last. Remember, mathematically, we could just multiply through by 1 over k, top and bottom. That's just like multiplying by 1. You can do that. The only reason I'm doing that is to show you well, I guess we should go one more step. What I did was, in the last one, let's go over here, is I multiplied, actually I made this, turned this into e limit. Instead of this function, I just made it e to the log of that function. But again, when you do a natural log of that, the argument of the log has an exponent. Well, that exponent can come right down in front. And so, again, e times, I'm going to bring this limit up top, e to the limit. That's a property of limits you can use since e is a constant. Limit of e to some power of k equals e to the limit of that power of k. And so we have the limit of natural log 1 over k plus 1. Okay. Instead of multiplying by k, I'm going to divide by 1 over k. That was a trick that we used to force this into the proper indeterminate form, such that we could use L'Hopital's rule. This, since we did this already, this is the last video, refer to the last video, that limit equals -1. So we're going to have e times e to the -1 equals 1. Okay, this is the limit of the ratio, absolute value of the limit of the ratio. Is this less than 1? No. Therefore, this diverges at that endpoint, which was the fourth root of 5e, diverges at the endpoint, meaning it diverges at the other endpoint as well. And so if you just leave off the equal signs, we don't have a less than or equal on either of these. It's an open interval, open-ended interval, and that's where the series converges for those values of x.